Hi, welcome to the third installment of Python Millionaire Retirement Simulator. And if you've stuck around this long, then hopefully you are interested in what we're getting at here. What we're going for is to make a retirement simulator that we can add more and more realisms to and make customizations for our own life situation, so that ultimately we could have a fancy and kind of interesting looking thing that can simulate how to plan for retirement. And of course, this is all mostly just to show off the math and the features of Python. I've been running this in the Spider IDE. However, in case maybe you're not, and I just wanted to show that if you're not, hopefully you shouldn't be having any trouble. So here I have my the same file, the retirement_simulator.py, and so it's just been saving itself as a text file. Everything looks exactly the same as it does in the Spider IDE. And here is my terminal window in the Python work directory, so that if I just run Python retirement simulator.py, it still executes with the same output. So $86,981.22 as of 20/34/08. And here's the test where we incrementally added money until we had $110 at the end of the year, proving that our annual interest rate was 10%. So we were validating our code in that sense. So if you've been following along here, hopefully you haven't had any difficulties. Again, I'm using this because some people like it, and I'm trying to just branch out and make sure that I'm up to date on all the different stuff that people use. So, okay. Well, as I said, last time we added this annual interest rate. We broke it down into what we called a paycheck interest rate, and then we did this one tiny thing where we added to our retirement this interest-bearing function here. So we added money, then that money earned some fixed interest at our paycheck interest rate, and that was all we added to the while loop. So this time we're going to add the feature of being able to pick a different interest rate from a Gaussian distributed or Gaussian distribution. And I've done this in a multitude of ways when I was building the simulation, but I'm going to show you the easiest one. And so we're going to import at the top the random module. And so there we have it, random. And I just want to check my notes here yeah. So that's what we need to do at the top. And so now we can go down here, and if you're using this what do you call it? This IDE, you'll get some of these helpful notes here. But if we say random.gauss, it gives you the kind of notes that you need to know about the Gauss function that's part of the random module. And so it's going to be looking for a mu as a float and a sigma as a float. So mu is going to be the mean, and sigma is going to be the width. And so if you're not familiar with a Gaussian distribution, that's okay. But basically, again, it's going to be a bell-shaped curve. And I'm going to help feed us with some realistic, semi-realistic mean and sigma. And so what the random Gauss function does is once you input a mean and a sigma, then it will sample as if it was sampling from a Gaussian distribution. So what we want to do is now we want to maybe say annual interest rate equals random.gauss, and we'll just say mean and sigma. And hopefully you understand that when I say mean, I mean average. So the central value of the bell curve. So we'll just define a mean value of 10%. Maybe we'll make it 7. I'm sorry, 07, not 70%. And then we'll say a sigma that's also equal to 0.07. Okay, and I'm defining it this way because there are some years where you might experience a negative interest rate, and so having this width be the same as the mean ensures that some of the samples that we get are going to be negative, which will be more realistic than always having a 6% or 7% return. Okay. Now we've defined this down here, so in fact, what we want to do is do our paycheck interest rate kind of underneath this once we've chosen our new annual interest rate. So our annual interest rate here is defined there. Okay. And so really though, this is only going to be it's only going to be interesting to sample this if we can sample it where the interest rate actually changes every year. And so we might like to build something into our simulation that can be sensitive to a change in the year. Okay? So to do that, we're going to invoke a few different things. One is we're going to, at the top of our simulation, we're going to say this underscore year equals today's underscore date dot year. And outside of the loop, we're going to start just by giving a pre-definition where we say year underscore check equals today's underscore date dot year. Okay. So today's date dot year should return just the year, and we're having a year check here. Then we define this year at the top of our loop, and so then we want to after we do today's date plus equals pay frequency, we'll say if this underscore year is greater than year underscore check, then I'm sorry. Yeah, if this year is greater than the year check, then that's when we want to do this annual interest rate sampling and then paycheck interest rate. So we're going to copy this and just put it in our loop here. And so we have to, yeah. Okay. So that's really all we need. Is the annual interest rate, is his random.Gauss mean and sigma, and the mean and sigma can still be out here. That's fine. And then the paycheck interest rate is calculated based on the annual interest rate and the paychecks per year. So all of that seems to be fine. And then outside of the loop, we need to do our year check down here, and in fact, I knew I was doing something today's date, so I need to do this year X after we add the week to today's date. So this year I need to do here. Okay. And that's what was getting me tripped up. I'm sorry. I was looking at this and thinking that something was wrong. So I'm sorry. Outside of the loop down here, but outside of the if statement, but inside of the while loop, we want to do a year check. And we'll say today's date dot year. Okay, so here's our year check, and we're going to check. This one should always match what we got for this year, I think. but this year here should change, should update with today's dates, increased pay frequency. So one time over the course of a year, this will trigger that this year is greater than the year check, and then that's when we pick a new annual interest rate and a new paycheck interest rate. So this is a bit in the weeds, and I'm sorry if it's too much so. However, I'm going to comment out this test for now. Let's see, cancel, I hit the wrong thing. Okay. And then we're going to just have it print our new annual interest rate every time it picks one, along with the year. So we'll say print this year, comma, annual interest rate. And the annual interest rate should be different every year. So we should really see the years change and the annual interest rates change. And then we will hit save. So we're saving that. And I'm going to run it. Unexpected indent for year check. Okay. And that could be that I'm using a tab when it's asking, it would like 4 spaces or something. Ah, no, I did it after my print statement, that's why. Which would be bad. Okay, that should behave better. Okay, so in 2022, we had a 2.5% interest rate, followed by a 9.4% interest rate, 17%, 3%, 6%, 11%, 12%, 16%, and then a negative 2.1%. So we didn't end very strong there, but so it goes. And that gave us 87,590, which I'm curious to see how that compares to our fixed interest rate. So that was similar to the average of having about 5% interest or 10% interest, whatever this was, over the number of years. But as you can see, we ended up with a different amount. And in fact, if we ran it again, 85.5 instead of 87.5. So now that we're using a changing interest rate, we see that we can't perfectly predict our final number of money in our retirement account. And of course, that's what we expect, right? A realistic model would be somewhat unpredictable. And yet, in the world of statistics, there are things you can do where you gather together an ensemble of unpredictable events, and then it allows you to make a best guess as to the most likely scenario. And that's where we're going with all this. So again, thank you for sticking in there with me, and hopefully we're making some progress. So I don't have another test for this one, but I think next time I'm going to introduce some plots. So we're going to plot some of these, this distribution of rates that we've selected, and we might just invoke a lot of different, selections of rates so that we can see clearly that we have a Gaussian distribution. And again, if you've never seen one, then you'd be able to see one for the first time. But some plots hopefully will make everything a little easier to understand. And if you're running this in your editor, if my editor then can update, see now it has all the same stuff in it. And if I run over here, it shows the new updated simulator. So if you do this in the Spider ID or the editor, it should be the same. All right, thank you for watching, and I hope that I'll see you in the next tutorial.